Jini is a revolutionary technology that simplifies the creation of distributed systems. Developed by Sun Microsystems, Jini allows different software components to seamlessly connect and interact. Imagine a network where devices and applications can automatically discover and use each other's services. This is the power of Jini. Jini is based on the concept of a federation, a collection of devices and software services that communicate and cooperate. Unlike traditional client-server models, Jini enables peer-to-peer interactions, where any device can both provide and consume services. This distributed approach offers significant advantages in flexibility and scalability. Jini's strength lies in its ability to adapt to changing environments. Devices can join or leave the federation dynamically, and services can be added or removed as needed. This dynamic nature makes Jini ideal for applications that require adaptability and resilience, such as enterprise systems, mobile computing, and the Internet of Things. At the heart of Jini lies service-oriented architecture, SOA, a design paradigm that structures an application as a collection of independent services. Each service represents a specific function or capability, such as data storage, transaction processing, or user authentication. These services communicate with each other through well-defined interfaces, regardless of their underlying implementation. SOA promotes loose coupling between services, meaning they can be developed, deployed, and maintained independently. This modularity enhances flexibility and agility, allowing developers to easily modify or replace services without affecting the entire system. Jini's embrace of SOA principles empowers developers to build distributed systems that are adaptable, scalable, and resilient to change. Jini's implementation of SOA leverages Java, a platform-independent programming language. This allows Jini services to run on a wide range of devices and operating systems, promoting interoperability and platform independence. By embracing SOA principles and using Java as its foundation, Jini empowers developers to create truly distributed systems that are flexible, scalable, and future-proof. One of Jini's key features is dynamic discovery, the ability for devices and services to automatically find each other within a federation. When a device joins a Jini federation, it broadcasts its presence and the services it offers. Similarly, when a device needs a specific service, it queries the federation for available providers. This discovery process is facilitated by a lookup service, a central registry that maintains information about all services within the federation. When a service becomes available or unavailable, the lookup service is updated accordingly. This ensures that devices always have access to the most up-to-date information about available services. Jini's dynamic discovery mechanism eliminates the need for hard-coded configurations and manual service registration. This self-organizing nature simplifies system administration and enhances flexibility. Devices can easily join or leave the federation without requiring complex configuration changes. Jini's dynamic discovery mechanism is essential for building adaptable and resilient distributed systems. Java Spaces is a core component of Jini that provides a shared data space for communication and collaboration between services. It acts as a virtual blackboard where services can post data in the form of Java objects and retrieve data posted by other services. This shared memory model enables asynchronous communication, where services can interact without needing to be online simultaneously. Services interact with Java Spaces through a simple set of operations: write, read, and take. Writing an object to Java Spaces makes it available to other services. Reading an object retrieves a copy without removing it from the space. Taking an object retrieves and removes it from the space, ensuring exclusive access. This flexible and powerful communication mechanism enables various interaction patterns, including request-reply, publish-subscribe, and task distribution. Java Spaces simplifies the development of complex distributed systems by providing a reliable and scalable platform for inter-service communication. Section 5. Leasing and renewal, ensuring service availability. Jini incorporates a leasing mechanism to ensure service availability and handle failures gracefully. When a service registers with the lookup service, it obtains a lease with a specific duration. The service must renew its lease before it expires to maintain its availability within the federation. If a service fails or cannot renew its lease, the lookup service automatically removes it from the registry. This prevents devices from attempting to use unavailable services. The leasing mechanism ensures that the Federation remains updated with the current status of all services, promoting reliability and resilience. Jini's leasing mechanism allows for graceful degradation in case of failures. If a service becomes unavailable, clients can automatically switch to alternative providers listed in the lookup service. This self-healing capability enhances the fault tolerance of Jini-based systems, ensuring continuous operation even in the face of unexpected failures. Section 6. Remote Method Invocation, RMI. Communicating with Jini services. Jini leverages Remote Method Invocation, or RMI, a Java technology that enables communication between objects residing in different Java virtual machines. RMI allows a client object to invoke methods on a remote server object as if it were a local object. This simplifies the development of distributed applications by abstracting the complexities of network communication. To use RMI, the server object must define a remote interface that specifies the methods that can be invoked remotely. The client object obtains a reference to the remote object through the Jini lookup service. Once the client has a reference to the remote object, it can invoke its methods seamlessly, regardless of its physical location. Jini's use of RMI provides a robust and efficient mechanism for inter-service communication. It allows developers to focus on the application logic without dealing with low-level network programming details. This simplifies development and enhances code maintainability, making Jini an attractive platform for building distributed systems. Scalability is a critical requirement for enterprise applications that need to handle increasing workloads and accommodate growth. Jini's distributed nature makes it inherently scalable, allowing systems to expand by adding more resources without compromising performance. Its dynamic discovery and leasing mechanisms facilitate horizontal scalability, where new services can be added to the Federation as needed. This allows the system to distribute the workload across multiple servers, enhancing performance and accommodating growth. Jini's Java Spaces technology further contributes to scalability by providing a distributed shared memory model. This allows services to communicate and collaborate efficiently, even as the number of services and data volume increases. Jini's scalability makes it ideal for building enterprise applications that can adapt to changing demands and support future growth. Enterprise applications demand high availability and resilience to failures. Jini's architecture is designed to address these requirements by incorporating fault tolerance mechanisms at its core. Its leasing and renewal mechanism ensures that only available services are listed in the lookup service. If a service fails, it is automatically removed from the registry, preventing clients from attempting to use it. This dynamic service management promotes system stability and prevents cascading failures. Furthermore, Jini's use of Java Spaces enables asynchronous communication, where services can interact without requiring simultaneous availability. This decoupling of services enhances fault tolerance, as the failure of one service does not necessarily impact others. Jini's fault tolerance mechanisms are essential for building robust and reliable enterprise applications. Despite its power and sophistication, Jini emphasizes simplicity in development and deployment. It leverages Java, a widely used programming language, making it accessible to a large developer community. Its API is designed for clarity and ease of use, allowing developers to create Jini services with minimal effort. Its dynamic discovery and leasing mechanisms simplify deployment by eliminating the need for complex configuration and manual service registration. Services can automatically join and leave the Federation, making system administration less cumbersome. Jini's simplicity extends to its runtime environment. It does not require specialized hardware or operating systems, allowing it to run on a wide range of platforms. This flexibility and ease of deployment make Jini an attractive platform for building and deploying distributed enterprise applications. Jini's innovative approach to distributed computing has a profound impact on enterprise applications. Its embrace of SOA principles, dynamic discovery, Java Spaces, leasing, and RMI empowers developers to build systems that are scalable, fault-tolerant, and adaptable to change. Jini's ability to handle increasing workloads, accommodate growth, and recover from failures makes it ideal for mission-critical enterprise applications. Its simplicity in development and deployment further enhances its appeal, allowing organizations to build and manage distributed systems with reduced complexity. Jini's potential extends beyond traditional enterprise boundaries. Its versatility makes it suitable for emerging technologies like the Internet of Things, mobile computing, and cloud-based services. Jini's ability to connect and manage a diverse range of devices and applications positions it as a key enabler for the future of distributed computing.